Hello everyone and welcome to the presentation. My name is Brian Tipper. I'm the CEO here at Stilo. In today's discussion, we'll be talking about tips and techniques for handling graphics when transitioning to Ditta. Okay, so let's begin. In many cases, moving to Ditta can be overwhelming, especially if your content is image heavy. So learning how to properly handle images will not only save you time and energy, but also provide reassurance that your images are correctly transitioned. In this talk, we'll look at many scenarios that you may have to encounter when moving your images over to Ditta. So challenge number one here is to extract image and XML data from Docx files. On this slide, you'll see the top portion of our Word document. So the document's a little larger. We just took the top portion to show you that you have a title there, some content there, and an image. And what we're going to do first is we're going to access the XML in the Word document. So what we need to do is we need to change the extension from Docx to zip. It should be noted that if you have a program like 7-zip, you can simply right-click on the Docx file and select unzip. However, if you're not able to do that, what I'd suggest doing is just make a copy of your Docx first, change the extension to .zip. Of course, you're going to have to say yes when it asks you, are you sure if you'd like to change the extension. Once you do that, you can right-click and extract all. And once you extract the content of the zip, you'll see that there's 3 folders and an XML file inside. The first folder, this _rels folder, is a directory that contains relationships for the files within the package. To find the relationships for a specific file, look for the _rels directory, that is a sibling of the file, and then for a file that has the original file name with a .rels appended to it. For example, if the content types file had any relationships, there would be a file called contenttypes.xml.rels inside the rels directory. Next, we have the doc props folder, which contains the core properties for any Office open XML document. And then the Word folder, this is the main part for any Word document. Then we see the content types file, which provides the MIME information for parts of the package. So what we're going to do is we're going to go ahead and jump inside the Word folder. Here we'll see additional folders and files. We have another _rels folder, which shows the relationships in the file, basically the location of the theme file and all the XML files listed below. And then we have a media folder, which is where all our images are stored. So what we're going to do is we're going to go ahead and jump inside the media folder. And inside here, you'll notice that we have all our images. That first image that was shown there, and then the other 3 images that are shown were actually at the bottom of the document. However, what you're going to notice is that all the images have default file names, image 1, image 2, image 3, and image 4. Now we can't change this. However, what we can do is we can pass image title information via captions, which is what we're going to look at doing next. So for challenge number 2, we're going to learn how to use image captions to create file names for the Ditta output. So to add captions, you just open up the original Docx file and right-click on an image and select Insert Caption. Type in a caption and hit Enter. And note that this will indeed push your content downwards a bit, but this is necessary if we want to go ahead and carry that caption information over to our Ditta so that we can name our images accordingly. So after adding the caption, we're going to go ahead and repeat the zipping and extracting process so that we get a fresh set of XML files. Now if we navigate to the document.xml file, which is inside that Word folder, and we go ahead and open that file, what we'll see is the following. And when navigating through the file, you'll see that there's caption markup, which is highlighted in red. And if you use a conversion tool, such as Stilo's migrate conversion tool, you'd be able to easily extract this captioned information and apply it to the image name when migrating your Word document to Ditta. And it should be noted that Along with captions, you can also use the alt text option. So the third challenge we have here is dealing with cropped images. May seem tricky at first, but it's actually quite straightforward. Let's go ahead and crop this first image from our original document. So this is the original image information. We're going to go ahead and crop it down to this these settings, which is basically taking the center two icons. So originally there were 4 icons. We're just taking the center 2 icons, and we're going to be looking at that. And this is now what the Word document looks like. So just to point out that we had 4 icons across here before. The image was larger, and we cropped out the center. And it should be noted that the new cropped image does get left margin aligned as we would expect. So this is important because you'll see later on that there is a negative X offset, and that's where that negative X offset is coming from. It's the cropped image being pulled over to the left so that it aligns properly with the margin. And now if you were to simply try to migrate this document to Ditta, you're going to get the full image. You're not going to get the cropped image, and this isn't what we want. We want the look of our Ditta to be the same as our look of our Word file. So let's go ahead and save the new file. We're going to change the extension to zip, extract it, and we'll see the following information or the following markup in the new document.xml file. So the tag a : source rect, this element that's within the pick : blip fill element, specifies the portion of the blip or image that is used for the fill. If no attributes are specified, this indicates that the image has not been cropped. Otherwise, the B, which is the bottom, L left, R right, and T top attributes specify the cropping for the rectangle. So each edge of the image is defined by a percentage offset from the edge of the bounding box. And you simply divide the numbers by 1,000 to get the percentage offset. So here we have all the percentage offsets for the left, top, right, and bottom. So we had these values, which you'll see here, which are actually all percentages, just 3 significant digits. And so we divide by 1,000 to get the actual percentages. So a positive percentage specifies an inset, and a negative percentage specifies an outset. So for example, a left offset of 25% specifies that the cropped left edge is located to the right of the original left edge by 25% of the original image width. Now when we migrate this content to Ditta, we can create an SVG with a view box that uses these attribute values to mock the cropping effect that was originally done in Word, thus giving us the exact same image that we had when we were in Word. And here we see the output after converting the cropped Word image to Ditta XML using Stilo's Migrate Conversion tool. So from the image properties, we're able to get the image width and height in pixels, which in this case were 882 pixels for the width and 281 pixels for the height. Now to calculate the view box, we need to calculate the crop width, height, X offset, and Y offset in pixels using the equations shown. So we'll just run through the equation for the width here. So this is 100%, subtract the addition of the left offset and the right offset, and you'll see these numbers again if we scroll up. Left offset here, right offset. So we take 100%, subtract the addition of those two offsets, and then we multiply it by the original image width in pixels, and this gives us the new width that we have for the cropping region. So a 447 pixel width for the cropped image. Do the same thing for the height, except you use the top and bottom, and because the height didn't change at all, it's still 281. We get the same value. Of course, the height did shift downwards a bit, so it's 14% downwards from the top and 14% downwards from the bottom, but the overall height is still the same value. Now, as I mentioned earlier, because the original cropped image, if we go back, because the original cropped image was in the center and it gets left margined, and also because the cropped region was pushed down, we also need to push it back up. So that's why you have a negative X and a negative Y value, because the cropped image gets offset in those directions. And to calculate the X and Y offset, we simply multiply the original pixel width or height by the left or top inset. And in this particular case, we had our image, as I said, left margin aligned, so that's why we have those two values. Now, once we have the width, the height, and the offset values, we can properly create a proper size and position view box that mocks the original word cropping. Okay, in this fourth challenge, what we're going to do is we're going to switch gears a bit. I mean, we focused on Microsoft Word up to this point. Now we're going to go ahead and take a look at Adobe FrameMaker. So for FrameMaker graphics, the options we have are, first, we can create an SVG from the FrameMaker graphic, which contains the callouts and an image link. The drawback of this is that there are two levels of links to manage: the link from the Ditta to the SVG, and the link from the SVG to the PNG or JPEG. Alternatively, we have another option. We can have the image itself be embedded into the SVG. So instead of a link, the SVG contains the base 64 encoding of the image. This means only one level of linking. However, the drawback is if the image is unsupported, such as TIFF, EPS, PDF, bitmap, or animated GIF, then it can't be easily replaced with a different image format. So the ideal scenario would be to convert your FrameMaker graphics to SVGs with embedded callouts and images, but using images that are supported by SVGs, such as PNGs or JPEGs. In this next challenge, we're going to do just that. So in order to retain the callout information in Ditta, we need to convert our FrameMaker images to supported SVG formats. So any TIFFs, animated GIFs, bitmaps need to be converted to PNGs or JPEGs. In this particular case, we've converted a TIFF, which you see on the left-hand side, to a PNG, which you see on the right-hand side, by integrating a free software tool called ImageMagick into our Conversion Tools file importer. And by doing this, we're able to automatically convert all our TIFFs to PNGs with a single click of a button. Okay, so challenge number 6. Now we look at the case where we have a FrameMaker drawing. Now, converting this image manually to Ditta is not very easy, and it involves a lot of parsing through the MIF file to find the individual elements. In this particular image, we have 6 black polygons, 5 white polygons, and multiple lines and curves. However, if you build a custom parsing tool to handle the job, such as we have done with our Migrate tool, you'll be able to automatically reconstruct this drawing into an SVG. And we show that in this markup. Now, we're not going to go through the entire markup, but you'll see that it's an SVG that has all these shapes and lines embedded within it, and they basically are the drawing itself. Okay, skipping over to challenge number 7 now. So in this challenge, we're going to look at converting embedded FrameMaker images with callouts to Ditta. So you'll see that we have 2 callouts here. We have a white circle with a number 1 in it, and we have a text box with the word Space Shuttle. And a lot of this comes down to being able to properly parse through the MIF file, and if you do that again here, and you're parsing it for the graphical information, you can recreate the image in an SVG. And we have done that again using our Migrate tool, which already has this functionality built into it. And you'll notice that in addition to the original image path, which you can see here, we have retained or preserved the following information. We preserved the white circle, the number 1 inside the white circle, and the text space shuttle. You can preserve as much information as you want, or choose not to preserve any of it. You're going to be the one parsing through, or maybe you're using a tool that does the parsing of the MIF, and you can decide what information that you collected that you want to pass over to your Ditta output. But here we show that you can pretty much get any information you want from these different images over to your Ditta results if you choose to do so. Okay, so this next image and our next challenge, this is an image from that's courtesy of the U.S. Geological Survey. It's a satellite image taken on July 4th, 2020, showing the Ottawa area. We threw in a bunch of complex callouts on this image, which includes 6 straight lines with arrows, 7 text boxes, a rectangle, a polygon, and a couple curved lines. And same thing, we're parsing through the MIF file, grabbing all this information, and we're embedding it inside the SVG. And this is what the results look like after we've done that with our migrate tool. And you'll notice that in addition to the original image path, we preserve the FrameMaker text boxes, lines, arrows, polygons, as well as the coordinates, the text formats, the stroke properties, and the color information. So that's it for the presentation. Thank you very much for listening to it. I hope you've all learned something useful for retrieving embedded images out of Word and FrameMaker. And if you have any questions, feel free to contact us at any time. Goodbye for now.